Welcome back. You can see I've decided to do this in a different way because using the zoom function on the laptop didn't make for a very good lab. So here we're going to do online lab number 3, conductivity of solutions. So we have sodium chloride and calcium chloride, and I made some 1 molar solutions. You'll learn how to do that in chapter 4. We have a conductivity probe and a beaker. Let me go ahead and take a look here at the setup. Okay, and I have a device here which will allow us to record those. Okay, and here I have my sodium chloride and my calcium chloride, and then I realized that I didn't have any Gatorade on hand, so I have Powerade and some of my kids' generic root beer. Okay, so let's go ahead and take a look at what we're doing. So first of all, and I'm going to try to kind of show this the way we would show it, we would do it in the lab. So the first thing that I need to do, okay, here you can see a graduated cylinder, okay, and I need to put 40 milliliters of water in here. Okay, so there I have about 40 mLs of water, and I will pour it here into my beaker. Okay, and now I have a little stir rod in there. You might be able to see it. Okay, and now what I'm going to do is I'm going to stand up so that it's a little bit easier to see some of this. And I'm going to start, and I'm going to keep a 0 point. And I'm going to put 1 drop of my sodium chloride into the solution. And then I'm going to come over and choose keep and tell it that I put in 1 drop. And you can see here the conductivity increasing. Two drops. And what I'm watching for is I'm watching for the conductivity to stop changing too much, because it takes time for our compound to completely dissociate. Okay. And now you can sort of see that we're starting to form some little dots there. All right, so that was drop number 3. There we go, we've stabilized. Oh, we haven't stabilized yet. I'm going to turn up my stir rod a little bit. The stir bar will, the faster it's going to some extent, the more quickly. Alright, there we go. And I can see the beginnings of a nice straight line. Oh, sorry, my video skills aren't very good. Okay. Drop number 4. And put in drop number 5. And if you've already looked over your lab, we know that we're going to 8. Okay. Almost done with this first part. And hopefully you can see nice and clearly that we have this nice straight line. And that indicates a direct relationship, which means that as volume increases, conductivity increases in a linear fashion. And the great thing about that is that we can plot a trend line and then use conductivity to predict anything along the way. And this is our last drop. Okay. All right. And now what I'm going to do is I'm going to stop this one. Okay. And then we'll turn this off. Okay. All right, so now we need to do this a second time with our calcium chloride. Okay. So I am again going to, oh, I can't see this very well. There we go. Again, I'm going to measure out 40 mLs of water. And you know what? I can see that I actually went a little bit over with that, and so I need to take out a couple of them, and I'm just going to use another beaker that I have here as a kind of a waste beaker. There we go. Okay, so we pour this in. And turn on our stir bar and bring the calcium chloride over so that it's handy. Okay, and now on my LabQuest here, what I'm going to do is I'm going to hit start again, and it's going to ask me what I want to do, and it says, well, I wish to store or append or discard the last run, and I'm going to store it. And now you can see that it's put me here on run 2. And the reason I'm showing you all this is because if you do go on and take Chem 2, hopefully it'll be in person, and you'll be able to work these yourself. All right, so this is our 0 level now. And it might be slightly different from our other 0 level just because like I didn't wash the little stir bar and things like that. Okay. And what I'm doing right now, it's hard to see, but you basically can wash a pipette in the new solution just by kind of like drawing it up a few times into the disposable pipette. Okay, and now I'm going to, oops, sorry, put a drop in. Now this second one is our calcium chloride. Run 2 is calcium chloride, and you can hopefully see that this is already going up a lot. And we're going to talk about why we see that in a minute. Okay? You're going to keep. That was drop 3. And drop 4. Drop 5. Drop 6. And here you can see that nice curve starting to form again. Nice linear graph. Okay, drop 7. And one more. All right. So that was kind of the first part here. And so now what we're going to do is we're going to come over here, and you can see I've got all of my data for run 1 and run 2. Okay, so now I'm going to just move this, and I'm going to bring my lab over here. Here you can see where my beaker wasn't quite big enough, so I changed this to 40 mLs. And over here I was doing my math for how to make my stock solutions. And now what we're going to do is we'll take a look here. So if I look at my run 1, Sorry. I can see that here I have 123, and this is where I'm putting in my conductivity. And then 209, 362, 492, 600, 724, 881, 995, and 1,151. Okay, so now let's go ahead and take a look at run 2. And here I started slightly higher, but that's okay. That's going to give me that 0 point. And then you're going to see that even though I started slightly higher here, that might just be a little contamination in the second beaker. But now watch how quickly this increases. 362, 563, 761, 953, 1,160, 1,369, 1,574, and 1,792. All right, now let's take a look at Y. So you can see that, and we can even come back here for a minute and let's look at our graph. And you guys are going to be plotting these as well. But let's go ahead and take a look at this, and I'm going to choose all runs. Okay, and now that run number 1, the sodium chloride, is there on the bottom, and it has a smaller curve than the one on the top. That's my run 2. And sorry, not a smaller curve, a smaller slope. What that smaller or more gradual slope implies is that we are not changing as quickly. The slope of the line indicates how quickly we are changing. And so the question is why? All right, so let's take a look at the back of this here, and let's talk about why we see what we see. Okay, here you can see I wrote, write the chemical equation for the dissociation of sodium chloride and calcium chloride in water. Now, what I'm going to do is I'm going to show you what we mean by dissociation. Okay, so instead of looking at sodium chloride and calcium chloride, I'm going to change that a little bit just because, and we're going to look at potassium bromide and magnesium bromide. Okay, now let's take a look at what happens with this. Now this is directly from my ion list here. Okay, so here you can see I can look, and there's my potassium, also my sodium, and my magnesium, and in my anions there's that chloride and bromide. So what I'm showing you is really similar to what you guys need to do, but this is just an example. Now if I take solid potassium bromide and place it in water, these two ions come apart, and that's what dissociation is. So we have K plus aqueous, that's what that AQ means, and Br minus aqueous. Now let's look at the dissociation for magnesium bromide. And again, it's solid and in the presence of water. Okay. And so we have magnesium 2 plus. And you see here how we have Br2. That means that we have 2 bromide ions. Okay? So now the important thing here is that here we have 2 ions. Here we have 3. And since conductivity, or the conducting of electricity, is all about the number of ions in solution, we would expect this one to conduct more electricity faster. Okay, so I want you guys to do the same thing for this chemical equation for the dissociation of sodium chloride and calcium chloride. And then you need to write a reason for that here. Okay? Now I'm going to pause and we'll do a second video for the sports drinks.